Right, Chapter 6, Lesson 41 is going to be on inverses and using composite function to determine whether things are inverses or not. So inverses can look like a pretty complicated idea. Essentially, all an inverse does is undoes the original function. So what I mean by that is if you start with some sort of input, put it into the function, and end with an output of b, if I put it into the inverse, I go back to the original, so it undoes it. So we have this notation here that if you have f of a is equal to b, then f inverse of b would equal a, because again, the inverse undoes the original. So what we're going to do is figure out, are things inverses, and then eventually find how to find those actual inverses. So from a mapping diagram, typically in a mapping diagram, this is your x coordinates here and this is your y coordinates here. So I would have h of 0 would equal 7, h of 4 would equal 3, h of 6 would equal 9, h of 9 would equal 12. From the inverse point of view, if I asked for h inverse of 9, it's referring to this 9 here, not this 9 here, because when I have the inverse part, now this is the y coordinate here. So from the bottom here, if I say h of 6 is equal to 9, then h inverse of 9 would equal 6, because again, you're going backwards for those. Okay, so if I have this as a function, and I want to find g inverse of -7, so I want to find the input of g that corresponds to the output of -7, or in other words, I want to find the x coordinate that goes along with the y coordinate of -7. Well, if I want a y coordinate of -7, here's -7 right here. And if I go straight across to that, that would be -3. So g inverse of -7 would equal -3. So again, from the graph here, if I had asked for g of -3, that would be -7. So that would mean g inverse of -7 would equal -3. Okay, so it depends again on your point of view, your reference of which one that you're using. Are you using the initial function or are you doing the inverse? So in what you're going to do today, you're going to find whether two functions are inverses of each other or not. Right? The pictures that I'm showing here, these are examples of graphically and with with your inputs outputs, whether things are inverses or not. So essentially, what happens with your inverses is your x's and y's flip-flop spots. So this would be a good example to look at right here. So again, let me show you what I mean with these upcoming ones here. This is just another diagram of this, but essentially with the composition of functions that you did in the previous lesson, if I do f of f inverse of x, I should end up with x as an answer. And if I do it in the opposite order, if I do f inverse of f of x, I should also end up with x as an answer. So if you do and undo and end up with the original answer, the two things are inverses of each other. If it doesn't, then they're not. So there's two different types of questions I'm going to ask here. First one would be, I'm telling you that these two things are inverses. I want you to show that they are. So what you're going to have to do then is you're going to show that f of g of x is equal to x, and then in the opposite direction, that g of f of x is equal to x. Because the directions say they are inverses, this is going to happen. You just have to show that it does. Right? You got to show the little bit of math behind it. Okay, so let's start with f of g of x. So if I do f of g of x is x plus 6 over 5. So I'm going to replace the g of x with x plus 6 over 5. And then I'm going to take the x plus 6 over 5 and replace it for the x in f's function. So that would be 5 times x plus 6 over 5 minus 6. Okay, and then algebraically, 5 and 5, I would end up with x plus 6 minus 6 plus 6 minus 6 is 0. You end up with an x for an answer. Okay? Same thing then when I go in the opposite direction. So if I do g of f of x, that will give me g of, again, I'm going to replace the f of x here with 5x minus 6. Then I'm going to put the 5x minus 6 in for x. So I would have 5x minus 6 plus 6 over 5. Now, the order that this goes in is minus 6 plus 6 is 0. So that would leave you with 5x over 5, which is equal to x. If on the test you just do this, oops, I'm going to mark that wrong. You need to show me the steps of doing it. Same thing with this one right here. If you just take the 5s and the 6s and cross them off, I'm going to mark that wrong. You need to reduce your 5s, end up with your x plus 6 minus 6, and then those give you 0, and you just have x for an answer. So you do need to show those steps when you're doing this. All right, same thing with this one. I am telling you in the problem that these are inverses. Okay, now notice this says here that x has to be greater than or equal to 0. If it's not, then this, when it goes in, won't work. So this part of the problem honestly has nothing to do with when you're doing these. It's not going to affect what you do. Okay, so again, f of g of x, g of f of x, do your substituting in. You should end up with an x for an answer when you do that. Okay, so take a look at those. All right, what if I'm asking you, are they inverses or not? Okay, so this one I'm not telling you that they are, I'm asking if they are. So this one, when you do it, when you do f of g of x, if you get x, when you do it as f of g of x and then g of f of x, if you get x for answers both times, then they are. If you do one of them and you don't get x for the answer, you don't have to do it the other way then they would not be inverses. And that's going to be the case with this one here. So if I start off with doing f of g of x, and I substitute in the square root of 4x minus 3 and then plugging it into the x here, this is what I would end up with. And I would end up with 4x plus 1 over 3 when you simplify that. That does not equal x. So I'm not going to even bother to do g of f of x because it doesn't matter. It won't be x either. So therefore, these things are not inverses. Okay, so make sure you know the difference between a question like this where it tells you they are inverses, which you then show that they equal x, and a question like this one where it's asking are they, and you have to see if you get the x or not. Okay, so it's possible, like just like on this one, that you won't get x for the answer. Okay, and then let's talk about graphing then. So I had mentioned in an earlier slide that when you're doing the inverses, essentially the x and the y flip-flop spots. Well, that's exactly what they do in inverses. So if I want to graph the inverse of this function, I'm going to take each one of the points that I have here and I'm going to flip-flop the x's and the y's and I'm going to graph those. So I would graph, instead of 1, 8, I would graph the point 8, 1. I would graph the point 4, 0 instead of 0, 4. I'd graph the point 0, negative 2 instead of negative 2, 0. And then 6, 6, when you flip it, is still 6, 6. Okay, so you're going to switch your x and y coordinates. So that's what I did with each one of these here, and then I connected them in the same order that they were on the original one. And then something to notice that we'll be talking about here with inverses is that if you take and graph the line y is equal to x, this will be a mirror version of this. So if you kind of take your paper and turn it 45 degrees so that the line's going straight up and down, you can see that those are mirror images of each other. Okay, so the things that you should hopefully be able to do is that show that two functions are inverses or not by doing the compositions, and then given the graph, be able to graph its inverse. So that's lesson 41. Let me know if you have any questions.